Welcome back to the Steffen Samsø Show.
My name is Mary.
And my name is Jane.
And today we're going to explain to you how tides occur and what kind of role the moon plays in this whole game.
To do that, we have a very simple theory to explain to you. It's called the equilibrium theory.
Excuse me? What?
The equilibrium theory.
Ever heard of gravity? Gravitational theory? Gravitational force?
Ever heard of centrifugal force?
Like, a stupid discussion. I can't, no. Every point of mass attracts every single other point of mass by a force pointing along the line intersecting with both points. The force is proportional to the product of the two masses and inversely proportional to the square of the distance between them. Yes, and that gives us the equation called F equals G M1 M2 over the R. Okay, so in this equation it's given that F is the force between the masses, and G is the gravitational constant, M is the product of mass 1, M2 is the product of the second mass, and R is the distance between the centers of the two masses. And then we have the equation for gravity.
Here we have the equation for the centrifugal force, and the Fc represents the centrifugal force, which is equal to m, which is the mass, times v, the speed, squared over r, the radius, which is the distance from the center of the object to the periphery of the same object. Because I have so much faith in this, I'm gonna put my life at risk to show you that this is a reality. Follow me. I'm about to boil some water, and I'm gonna fill it with this cup and swing it around my head. So we're just gonna wait. Are you guys ready? I can assure you that this is boiling water. Look. Alright. In science I trust.
Okay, so that is what causes the tides. Now, as far for the time that goes from one tide to another, at a given point of the day, you might think that it's 12 hours due to the whole like 2 tides a day thing, but it is in fact not. It's a little bit extra, and that is because often when we do this math, we neglect the fact that the moon also orbits the Earth. So what we do is we say that we know that the Earth rotates around its own axis in 24 hours. Right, and that is 360 degrees. On top of that, we have to remember that the moon also orbits the Earth, and that is an extra 360 degrees every 27.5 days. So if we divide 360 by 27.5, we get 30 degrees to be added on top of these a day. And that gives us an extra 25 minutes per tide, which means that there will be 2 tides a day. No, there will be 2 tides every 24 hours and 50 minutes. Yes, so that is that. That is why the tides are displaced.
Now it's my turn to explain how the tidal forces work. Well, I'm gonna explain to you the equilibrium tidal theory. And this theory doesn't differ a lot from Isaac Newton's theory about tidal force, or tides. The main difference is that the tidal force isn't only influenced by the gravitational pull, but also by the centrifugal force. According to the equilibrium theory, tidal theory, we would only experience tides once a day if the Earth didn't rotate in a tiny circular inner orbit. But as we have discovered, we experience tides within an interval. Hvad findes det?
En hvad?
Et interval.
Interval. Timelap.
Timelap. Okay, så lige den lige.
Timelapse måske, det ved jeg ikke. Tror du det?
Timelap.
Interval. Jeg kan også bare prøve at sige interval, og så se, hvad der sker.
Okay. According to the equilibrium tidal theory, we would only experience tides once a day if the Earth didn't rotate in a tiny circular inner orbit. But we have discovered, as we experience tides within a time lapse of 12 hours and 25 minutes a day, that can't be the case. So, of course, the water, the side that is facing the moon, is pulled by the moon's gravitational force. But we know by a fact that the opposite side of Earth's water also rises when it's facing away from the moon. And how can that be? Well, wouldn't it be pulled towards the Earth's surface instead of away from it? No, it wouldn't. This is when the centrifugal force kicks in. We have a short animation showing the Earth rotating in an inner orbit, causing the centrifugal force to affect the side. So to sum up, the bulge facing the moon is caused by the gravitational pull from the moon, and the bulge facing away from the moon is caused by the centrifugal force, of course, created when the Earth spins around in a circular orbit around itself.
We know by a fact that gravity is a reality.
But at least we can count on centrifugal force. Or let's just cut it. And thanks for watching. We will be yes.